Good afternoon, everyone. I'd like to thank the organizer for organizing this very good and beautiful event, and welcome to my presentation. My name is Shamim Ahmed. I'm presenting our research work. Recently, we are working on that is evaluation of machine learning algorithms on NILM using semi-synthetic training data set. So my colleagues Leo and Marx are also with me for this project. Here is the outline of my talk. I will briefly describe about Fludia. Some of our solutions we are giving to our customer, then exploring NIM and semi-synthetic illustration. Then I will explain a little bit about the machine learning algorithm that we are treating for this activity. In the data set we have studied for this presentation and the result and some future work. About Fludia, it is an eco-innovative company. It's founded in year 2005, and we are mostly producing sensors for smart buildings and smart homes, and that collects the data from the existing meters, electric meter, gas meter as well. And obviously, our clients are mostly for energy efficiency integrator, like power suppliers and so on. We have a quite small team, but not so small as well, with a number of engineers, researchers, and some other person from the marketing department. We are deploying our product for many years, and we have experience over more than 50,000 of already developed sensor for the meters. And then finally, I'm just introducing myself a little bit. I did my PhD in 2018 March in signal and image processing. And there I worked mostly on machine learning algorithms applied in non-destructive testing. Little bit a different area that right now I am working on. And then I started to work with Fludia as a machine learning researcher. Here is some of our solutions. As I already said, we produce optical sensors, which are really cheap with respect to smart meters. And this optical sensor are plug and play. It can be placed with the existing meters, and it is very easy to install. Required a small amount of time, with a couple of minutes. And it's very useful for data analytics for NILM and other types of activity for the other operators and so on. And also, these sensors are useful for IoT capability. As I said, the data can be transmitted to the cloud through local area networks or Sigfox or local radio network. Exploring NIM. Behind this optical sensor development, we have our team which is working for in-house research for NIM activities like energy disaggregation. But until 2018, we are working for mostly probabilistic in-house approach, but it is only for our own research. We are not giving this solution to our clients. And from 2018, we are also moving towards some machine learning applications for energy disaggregation. And mostly we are interested for 1 meter active power curve because we have already the sensor to take the information from the existing meter. So at the beginning of this work, we focus some of these criteria that we are interested on. That means we don't have so much houses in real world data set. We need so much data. Then not enough diversity of the appliances, because in real life there are lots of different houses and different appliances can be exist, and we need some sort of diversity of the appliances. And then machine learning as well as deep learning algorithm needs too much data. How can we get some solution for this one? So we can do some mix of appliances measurement and generate some synthetic data. It can be done by simulations and by randomly scheduling, by scheduling with for the number of people exist in the house or outside of the house. And then we can generate some semi-synthetic data. You may be thinking of what is semi-synthetic. You are producing synthetic data is a simulator. Why it is semi-synthetic? Okay, the main thing is At the beginning of the simulator, we put some simulation parameters. It can be number of person are in the house and the availability of the person in the house. But we use some real appliance measurement. That means appliance signatures. It can be available from different data set like trace we are using. Then we have our own data set from our sensors. And then behind this, there is some engineering model that we can also include for some appliances behavior like stove, oven, or some other noise model we can use for this one. And then we use the simulator, and at the end we get aggregated curve and individual load curve for this aggregated data. Let's have a look how it looks like when we finally get some signals after the simulation. So on the top, it is showing the blue curve is aggregated data, and in the down in the appliance measurement curve, load curve, for 2 days. But it is a little bit complex to see. So let's see in the zoom area for this one how it looks like. So you can see that in the bottom, the appliances are showing different appliances curve, and the active period of this one, and the corresponding aggregated. Seems like, okay, it is simulated based data, but can be quite realistic. We cannot say that it is realistic because it's semi-synthetic, but does it have some influence on the training model or our data set? It can be useful or not. Okay, then we fix our goal. Let's play this data set or simulated based data set for machine learning algorithm for energy disaggregation. So what we did, we have chosen some machine learning algorithms. Like I have worked on a couple of these, so it was at the beginning my idea was to use those existing algorithms like kernel regression, then for a decision tree, and k-neighbor regressions. From some of this experience, I found that okay, each of these algorithms perform maybe better from one appliance and better from another appliance, another algorithm. So why not combining all of this using some stacking regression? It's nothing but is a linear combination or linear stacking of a different regression technique that I have mentioned here, 1 to 4. So I perform this analysis for some data set. Let's see how this data set is done. For the training algorithms, we use 10 houses for real world data set. And then for the semi-synthetic data, 10 or 20 or as many as you can produce. And for comparison, we also use 10 real test houses, means 10 real houses which are used for testing, which is totally different from training. And for all of this case, training and testing, we have used 1 minute interval data for 2 weeks period. So how this real world data set has been done? Okay, at the beginning, I was really struggling because you see repeat, echo, UKDAL, all of them are different data set. And if I perform one single training set, but testing in different data set, obviously it is a very difficult task. And not all the machine learning algorithm give a good performance. So we just select all of these houses and combine this and randomly select 10 houses for training from the real data set and 10 houses for testing. And then, as I already mentioned, semi-synthetic data has been generated, and then we have used trace for individual appliance measurement, and as well as our own database for each appliance measurement, and some basic daily profile from the user level. Here is some result that I am showing the comparison between machine learning algorithms for training 20 simulated houses, and then testing on 1 real houses. And this house is very well known. It's a UKDAL dataset, house number 2, and the time period is also given. And now I'm showing the error metric of relatives error for total energy consumption. So you can see here, different appliances are showing differently for different machine learning algorithms. So for example, Here, washing machine rainforest is showing something better performance in terms of lower relative zero. In case of dishwashers, SKR mean stacking is showing good, and so on. So on average, on different experiments we have performed, we found that okay, SKR can be on average a good machine learning algorithm among all of these, can be used for our next analysis. So here is the same training and test set. I am showing how it is performed for the case of by using SKR in terms of actual versus predicted energy consumption. So we found that it is not so bad for the test house UKDL dataset house number 2 for 2 weeks. But because you can see that training and test energy consumption are almost good for dishwasher, washing machine is quite comparable, and so on. But does it show that our approach is very good? Because it is only one house. It may happen that it is suddenly giving a good result, but not for others. So we have done this experiment for over all the test house, like 10 test houses. So here you can see that there is a comparison between 2 different training set has been applied, 10 real house and 10 simulated house, and tested in test real houses. So the relative error is calculated by averaging all the error for each houses. So you can see that, okay, for the case of freeze, simulated error is a little bit lower than the case of real house training. But freeze has almost similar, microwave is almost similar. Sometimes the real house it has good accuracy on a washing machine. But case of dryer, okay, simulated house is showing much better result than real. How it is possible? It may be possible because maybe we have used different varieties of dryer in the training set, because we can produce as much as we want. And then, but it is opposite in the case of dishwasher. Maybe we have used the dishwasher in the simulated house, which are not present in the test sets. So the dishwasher is showing better performance for real houses. So we have to that compensate this. Sometimes it is good, sometimes it is bad. But the main goal of this study is not to show that simulator is the best one. This is to show that we can use this simulation data if we need for a big data set on variety of data set. So we increase the number of training set in the simulated houses. So we can see that, okay, now freezer has decreased the error rate for simulation, and the freeze almost lower. Microwave also it decreased. Washing machine little decrease the error, but dryer it is not decreased in this case. Dishwasher, okay, the error rate has been decreased. So in a different experiment that I have performed during this analysis, we found that we can also increase from 20 houses to 40 houses, and then it really improved the performance of freezer estimation, dryer estimation. But we are still struggling for the case of dishwasher, how it is performing. I hope so. We will find some solution in future. So here is some of our future goals that we are thinking that, okay, we can use some of the probabilistic approach that we had used in Frudia before and combine with these different machine learning algorithms for different appliances. Can be done. And then exploring some machine learning approaches, maybe deep learning, obviously. You can see that how it is performed. It is performed for simulated based data. And obviously, we are just working on the simulator. It is not like it is a very wow simulator can give us very good result as like real. We have to work on this, like including human behavior, the presence of the people inside the house, and so on. And also, we welcome all the industry partners and universities so that they can share and we can share our knowledge or with some collaborative work. And that's all. Thank you. And for any types of query, you can contact with us.